Dear students, welcome to the course of Essence of Indian Traditional Knowledge. Today's topic Mathematical Sciences in Vedas. In our previous lecture, we have learned the medical sciences and its relevance in Vedas as a part of Indian knowledge system, where it comes under the Upaveda of Upaveda called as Ayurveda, which is derived from Atharva Veda. So presently, in this topic, we will deal with mathematical sciences in Vedas briefly. After completion of this lecture, you will be able to identify various contributions of Indian mathematicians in the Vedic era. Going into the details of mathematical sciences in Vedas, mathematics in its early stages was developed mainly along two broad overlapping traditions. One is geometric and the other is arithmetical and algebraic. Famous mathematician, that is A. Siedenberg, an eminent algebraist, historian of mathematics, traced the origin of sophisticated mathematics to the originators of Rig Vedic rituals. So, the two main broad overlapping traditions, that is geometrical mathematics and arithmetical and algebraic mathematics, have got its roots into Rig Veda. The oldest known mathematics texts in existence are the Sulva Sutras of Bodhayana, Apasthamba, and Katyayana. So, based on their texts, the existence name is Sulva Sutra, which is a part of literature of the Sutra period of the later Vedic age. But the mathematical knowledge recorded in these sutras, that is known as aphorisms, are much more ancient. Going into few more details, Sulba Sutras, to name a few, one is a Pythagoras theorem, which was in fact formulated by Euclid around 300 BCE, but this is present in Sulba Sutra in ancient India as part of Vedic literature. So, what is its significance is to construct a square resulting from the addition or subtraction of two other squares. So, that is area A and area B are the two squares. So, you can construct a square with area C, a summation of area A plus area B. And all these procedures were purely geometrical but led to interesting corollaries. So, one of such kind is the racial approximation of root 2, which is corrected to fifth decimal, that is root 2 is 1 plus 1 by 3 plus 1 by 3 into 4 minus 1 by 3 into 4 into 3, 4. So, that value will be resulting in root 2, that is 1.414. This is only 3 decimals, but up to fifth decimal. And under Sulva Sutras, we have few more details. Sulva Sutras also introduced a system of linear units. Most of them are based on dimensions of the human body, where not like the present units, human body dimensions are the root for the units of various quantities. And later they have been modified and they became the traditional units across India. So out of which few chief units are, one is 14 anus, that is regarded as 1 angula, that is a digit. So basically anu refers to a grain of a common millet, and 12 angulas is represented as one pradesha, the span of a hand, later vitasti, and 15 angulas is referred to as one pada or big foot, and 24 angulas is referred to as one aratni, so that is referred to as a cubit, later it is also called as hasta, and the measurement 30 angulas has got the units of one prakrama, or this is referred to as a step. One step made by a human body is referred to as one prakrama, that is equivalent to 30 angulas. and 12 120 angulas is referred to as one Purusha. So this is a height of a man with his arm extended over his head. So as I mentioned, all these units from Vedic literature, linear units, are based on dimensions of the human body. Here, few are listed for our reference, and these units are later modified as traditional units used across India. And coming to the number system in mathematical sciences in Vedas, numerals as they appeared in early inscriptions. See here we have Brahmi inscription here in the period of Ashoka, and Nasik inscription is there, and Nanagat inscription is there. In these inscriptions, note that they do not yet follow a decimal positional system. But for instance, in the first column, if you see in this figure, 40, the number 40 is represented as, is written as 20, comma 20, that is representing the symbol of 3 3. And whereas 60 is represented as 320s, 20 20 20, that is 3 3 and 3. So these are the inscriptions during uh, Saka Pradhan Kusana. And similarly, we have Ashoka inscriptions and Nanagat inscription and Nasik inscription. Brahmi literature, this is called as in Vedic text. And few details about number systems. This evolution of Indian numerals, as evidenced by the inscriptions, the first script is Brahmi script, that is used by Ashoka in his edicts, and last is an antecedent of Devanagari script. So here the representations are given. So Brahmi numerals around 1st century, 1 is represented as dash, 2 is represented as double dash, 3 is represented as triple dash, 4 is represented with plus and various symbols like this. This is what we call it as now in nowadays in digital systems, binary representation, then octal representation and hexadecimal representations. And whereas in Gupta period also there are numerals, that is in the 4th century there were few representations, and Devanagari numerals around 11th century AD, the representative symbols for the digits have been changed a little. And here you can have a brief overview starting from 1, number 1 to up to its 1 into 10 power around 10. Right, so all these have their names as starting from Ekam, Dasam, Satam, Sahasram is 1000 up to Pararardham, that is 1 into 10 power 10 around. So these representations are there in Vedic literature. And coming to the famous mathematician which is known to all of us, that is Aryabhatta, about 499 CE, living near what is today known as Patna. Aryabhatta was born and authored Aryabhatiya. This is a book authored by Aryabhatta. So, what is his significance is the first extant Siddhanta or a treatise attempting a systematic review of the knowledge of mathematics and astronomy has been prevailed in his days. In the days of Aryabhatta, systematic review of the knowledge of mathematics and astronomy linked together has been prevailed. The mathematical content that is developed by Aryabhatta ranges from, one is a very precise tables of sines and precise value of pi, that is 3.1416, stated to be approximate, has been given by Aryabhatta, and the area of the triangle is formulated for the first time, and the sums of finite arithmetic progressions, you say arithmetic progression, that has been given by Aryabhatta, and the algorithms for extraction of square roots and cube roots were given by Aryabhatta, and an elaborate algorithm called Kutaka, that is pulverizing. So what for this is used is to solve indeterminate equations of the first degree. For example, equations like ax plus c is equal to by. So such equations to solve, those are indeterminate equations. In order to solve, an algorithm was given by Aryabhatta. And here you can see the figure. half chord of an arc of a circle AB is equivalent to sine alpha. This is known to as sine alpha is representing water. Then when we come to Brahmagupta's classical period, Brahmagupta was an imposing figure, considerable achievements in mathematics he has got. He has made a very good contribution called Brahmasputa Siddhanta, where he studied cyclic quadrilaterals that is inscribed in a circle like this, in which he has given the semi-perimeter of that shape as a plus b plus c plus d by 2 and its area over the root of s minus a into s minus b into s minus c into s minus d it is. And Brahmagupta introduced the notion of negative numbers. This is very important. And he also has defined mathematical infinite as Kacheda. That is, when Ka being one of many names for 0. So, if something is divided by 0, that should result in an infinity. He also has discovered an algorithm named Bhavana for integral solutions to second order indeterminate equations called Varga Prakriti. So, such equations are of the type of nx square plus 1 is equal to yx square. So, he was in many ways one of the founders of modern algebra, and his works were translated into Persian and later into Latin. And one of the contemporary mathematician of Brahmagupta is Bhaskara. So, who did a pioneering work in the field of trigonometry. So, he has proposed accurate rational approximation of the sine function. So, whatever you are seeing is a sine function, where the graph here is showing the high accuracy of Bhaskara 1's rational approximation for the sine function from 0 degrees to 180 degrees. So, that is from here to here. The sine function in red had to be shifted upward by 0.05 to make the two curves distinguishable, rational approximation and sine function. Right? So the first part of Bhaskaracharya's Bhaskara 2, that is Siddhanta Siromani, is a collection of mathematical problems called as Leelavati, named after an unknown lady to whom Bhaskara puts problems in often poetical language. So this book, that is a set of mathematical problems, Leelavati, became so popular with students of mathematics across India that 4 centuries later, Akbar had it translated into Persian by a court poet. So one of the problem from Leelavati in the form of poetica. Here is an ancient problem from Bhaskaracharya's Leelavati. Beautiful maiden with the beaming eyes, tell me which is the number that multiplied by 3, then increased by 3 fourths of the product, divided by 7, diminished by one third of the quotient, multiplied by itself, diminished by 52, the square root found, addition of 8, division by 10 gives the number 2. Well, it sounds complicated, doesn't it? No, not if you know how to go about it. So, these are few lecture level questions as far as this topic is considered. You can solve these questions. That's all for this topic. Thank you. Happy learning.